Okay, so back at our capture point, before we went off on setting the player health, let's go ahead and get the player health. Okay, and we want to check, is it greater than 0? Because if it is, they're alive. Okay, so what we're going to do is we're going to make a local variable, and local variables are great because they a lot of people want to make member variables, which are things that are always there. They're always stored in memory. When we make a local variable, when the function goes out of scope, the memory that was used to store that variable all gets freed up again. So they're very. I used to think the opposite. I used to think, oh, I'm making all these variables. It's costing all this, performance. And yeah, there is some, cost to make the local variable, but it's much better than making a member variable. So we're going to do that. So just to ease things up, so we get of the same type. This is a really quick shortcut. Just right click over here, promote to local variable, and we're just going to call this living players. Now I did that as a shortcut, okay, just so I made sure I had the right type of the third person character. And as you can see, I disconnected it here. I don't want to actually set characters to living players because they're not all living. So let's delete that right there. Let's grab our new local variables, which hide sometimes under this drop down on the left corner. Let's get it right here. Okay, and we're going to add unique. You could probably get away with just doing an add right here since this is a local variable and we're running it for the first time, so you're probably okay, but just to be a little OCD, and because there's not hundreds and hundreds and hundreds of characters, it's not that much more expensive to have the peace of mind that you've only added the player once. So that's what I did. And you know how I was trying to show you that shortcut to be all fancy. I actually made the mistake, and we don't need them to be third-person characters. I mean, it's good to know you could do stuff like that, but let's change the type. This is a good example of how you can change the type, and we're going to change it to, I believe, let's see, yeah, just regular old player state. So let's do that. So you see how it's third-person character? Just type in player state. Okay, and we're going to do the object type. Change variable. You'll get a bunch of stuff popping up like that, whatever. Okay, we're good. And you're probably going to have to redo that add unique, because the add, whenever you do a note after there, it's specific to the type, so it'll probably throw an error if you don't delete that add unique after having it as the character type. We want to actually get the player state type. Let's go over here. And then since we have the characters spitting out of here, you just get your player state. All right. Add it in here. Clean this up a little bit. Let's see, what can we do? Go down here like that. Clean it. All right. So now we clearly could pull off of here rather than use our sequence, but things get messy and it can get very confusing. Once again, somebody's quickly reviewing your stuff or adding to it, they're almost always going to mess this up. So it's much better just to have a sequence node here. We can just keep things so much cleaner. So let's do it that way. Right click, convert to a validated get. Bring it off over here. And see, this, I probably should put this in a comment box, but I'm going to select it, arrow it over just a little bit so that way we don't have anything overlapping. Okay, so I have my game state. Now, there's several times in the game state, I'm going to want to know the team and the player count, but I don't want to always know it for the same set of people. Sometimes I just want it for living players. Sometimes I want it for all players in the game. So we need to make a function that can take the parameter of what players we're talking about. So, and then it's going to spit out, okay, what players are on what team based off what I feed into it. So let's go over to our game state and create that function. Save what I got. Okay, we're going to call it create team player count shift key. Does not want to work for me. Okay, so what this thing is going to do, it's going to take an array of player states to start. Because remember I said it might be living players, it might be all the players, based off how we're going to use this function in multiple spots. So let's do the type. Remember the player states like the soul. Good to keep that in mind as to what this is. It's not the character. Let's get the array version. Call it in players. Okay. What do we want to return out of this? Well, we want to return what's called a map. And a map is a really organized way of having one thing that talks about another thing, and it's an array of those. So it's a collection of those. So I'm going to show you what the one thing and the other thing is. It'll make more sense. So it'll be a team and its count. And so we're going to have two teams and their counts. And if, let's say you had 20 teams, you could have 20 teams, each team, and then and its associated count. Just a really organized way to handle things. But to make that map, I want to have your teams, and I want to have those, I want to have them, I don't want to just have them be team 1, team 2, team 3. I want to have very unique things about the team. Like I want it to say maybe team 1, team 2, no teams, both teams, something like that. So to do that, we'll use what's called an enumerator. So we're going to have a nice organized way to talk about our team. So let's go back into our third person template right here, and let's make an enumerator. Okay, so let's see. What do we want to call this thing? We could go E. Usually enums start with E. Team. This might be a little redundant. E team enum. All right, but it's fine. Okay, so let's open it up. Enums are very simple. It's just basically a number that has a name associated with it. So for the first number, let's say it's 0, we're going to just call it no team. So 0 equals no team, 1 equals team 1, 2 equals team 2, and then 3 is going to equal both teams. If you didn't do this, you would have to be like, okay, I know 1 and 2 is team 1, team 2, but is 0 no team or is it both teams? It's just a way to stay organized. That's all. Nothing more to it. Okay, let's go back to where we were. Okay, in our team player count map. And so like I said, create team player count map. So to do that, we're gonna mess with our output. So in our output, we click the output drop down. Let's see if it lets me do this right away. Okay, I can select map. Okay, and so for the first part of the map, I'm going to want that to be the team. So we have our team enum. All right. Oh, and I just did it to the wrong thing, so let me control zebra that. Okay. Our players are still player state. I meant to do it to the output. That was the mistake. Okay. Do the drop down here. Let's type in team. Team enum. Cool. So we have the team. Let's name this. Team count map. The team is the first part, counts the next. So what's over here then? Let's make that an int. It'll be an int 32. They just call it int here, so well better than the int 64. A little cheaper. I'm not going to have a bazillion people. So that's good. We'll develop this function more later. It allows us to continue on with our capture point logic. So let's continue on there. Okay, so we can drag off of here and we can say create team player count map. Okay, that's the thing we just made. Let's get our living players. Drag them into here. Okay, so what are we going to do after here? What we're going to do with the map's pretty cool. So it's better than an array. Well, it's unique to an array. One thing about maps is they can't be replicated, so that's its major limitation and why we don't use them for everything. So let's drag off of here and say find. And we're going to say find team 1, right? And then I want you to find team 2. And what this does is when you say find, it goes through the first part of the enum, which is the team, and then it returns the second part, which is going to be their count or their score that we're going to use it for. So it's the team count map. You're returning count. It returns a bool if it actually finds it. Okay, and what we should do at this point is to make this very clear what we're doing, we're going to right-click on one of these. We're going to promote to a local variable. And just type in team1 score. This will make our function a lot more clean. Do it again over here. Go to a variable, team2 score. Oh, I made it a member variable. Let's just delete it from over here. And you could tell divided between variables and local variables. Team2 score. Okay, that looks pretty good. And instead of score, maybe count would be better. We're gonna score based off these counts, which is kind of where I was laying. But we'll just do team 1 count, team 2 count. You could say player count. You can name a score count because that's what Capture Point really cares about here. All right, so we got the team 1 count. Let's get it. We got the team 2 count. Let's get it. Okay. We're going to do different things based off of what these things are. So if they are equal, double tap the equal sign twice. The reason it's double equal in C++, the single equal is a way you store values. So the double equal means actual equal. It's kind of silly, but that's the way they do it. Press B for the branch. So what are we going to do if these teams are equal? Okay, so if they're equal, we're basically going to return that there's no we're going to return that there's no team that's scoring, because if two teams of the same count are on a point, nobody's going to score. So I want to return that value. So to return that value, if we were, I would want to return the team and the score. Okay, and so we have the map, which will give you the team and the count, but it's in a map, which means it's like an array. It has multiple entries. We simply want to return just the team and the score. Now, C++ has a great group for that called a T-pair. We don't have that in Blueprint. So there's lots of ways we could do this. We could be sloppy and just have a map with one entry and get the zero array entry of the map. I don't like that. So what we're going to do is we're just going to make a struct, and it's just going to hold the team and the score. So let's do that real quick. Okay, so we're gonna make it a struct. So just go ahead and right click somewhere over here. Let's see, under Blueprint maybe. There it is, structure, and we're gonna want it team count struct. Let's open it up. So what's the structure? Okay, it's just it's your definition of a variable type. That's all it is. I can put whatever I want in here. Think of it like a container type of whatever you want. So what we're going to have in here, and you're going to see what it is when I make it. So the first thing will be the enum, and it was the team enum. And then we're going to add player count, integer. Okay, so that's all there is to it. So it's just a container that holds our team and player count. Okay, and so how are we going to apply that to this function? Well, we're going to make it our return value. So on the output, click the plus, do team player count. And I named it team count, not player count. Team count struct. There it is. Okay. And so then compile that. Grab my output. And to make that even more specific, we could say team and number of players, because that's what the count really is. Let's just over here. Now you could split the struct pin, right click. Yeah, that'll do it right there. So for this situation, we want to say note, because the counts are equal, so no team. But I think it would be handy to know what that value is if for whatever reason you wanted to like show little icons that said, hey, there are so many people on here and that's why nobody's scoring. Like there are 2 people from each team. So no team, and it wouldn't matter which one you pulled off of here, right? Because they are both the same thing. You could pull off 1, you could pull off 2. It doesn't really matter. So there you have it. Now, you know what? That's going to drive me nuts. There. Because we're going to pull off this executable. So if they're not the same, what do we do? Okay, so let's bring out the team 1. Team 2. Okay, so if team 1 is greater than team 2, we're going to do something. And if it's not greater, we're going to do something else. So that will handle all our conditions, because if we handle equal, we handle team 1's greater, we handle team 2 is greater, which we're going to show here in a minute, then it's going to handle all the possible solutions. So what we can do at this point is we can run off a select node. All right, and basically what this says, hey, if team 1's greater than team 2, do this. If it's the other way around, do that. And that handles all of our situations. So to make that struct, we're just going to type in make team count struct. All right, we're going to plug in 1 for a false condition. Bring this down. Run that for a true condition. So what's the condition? All right, so if team 1 is greater, so they got these flipped. This is always, I wished it was the other way around. So if team 1 is winning here, then it's going to be team 1. If that's not true, then it has to be team 2. Okay. But we don't want to just pass on their counts, right? We want to penalize the other team if there are other members from the other team still there. So how do we do that? Well, let's drag these off. We're going to take the team 1 count and we're going to subtract it. We're going to subtract the team 2 count from the team 1 count. So what this will do is if there's 2 players from team 1 and 1 player from team 2 on the point, they're only going to get credit for 1 player. So they're penalized. And if they take that other player out, then they're going to get their 2 player capture rate, which will be much faster. The more players on a point, the faster we're going to do it. At least the faster it'll be captured. That's what we're going to do. So let's copy this over here. Let's just change the order. So if team 2 has more players, you just inverse that. So like that. Drag it into there. Bring it all up. Put it down here. Just type in return, add return node. There you go. Okay, and then that will come out of the false. Okay, one thing to make sure of when you're dealing with anything that has a return value, and I'm guilty of doing this all the time, to make sure that all conditions actually return something. So I believe we have a condition here where it can fail. Here we'll come on to here. So when you're like, I'm not sure about all the fail conditions, let's say this logic is really complicated. You can this is common to do too. You can add a third right here. Third condition. And then let's add a return node. Oh, not a parameter. Right click. Make it. Okay, coming over to here, add a nice little reroute node to keep that organized. And so while Blueprint itself won't throw an error, it's going to allow you to not have a return for every condition. Yeah, see, I don't like how when you zoom out, it blends them together, but whatever. This will be good enough. So my point was, in normal code, you would have to provide a return condition. It would throw an error. In Blueprint, it doesn't. But once again, we're trying to keep things consistent here, so we should definitely have a return. It also gives you an expected value. It might not be what you return might not be what you expected if you don't specify something here. So this is going to be a catch-all, because in all other conditions, it's going to handle itself, right? It's going to be like, it's going to go through here. It's going to return. It's never going to get down to this third executable. However, if this fails, for whatever reason we don't have a cached game state, or something else that we didn't consider fails, we need to have a catch-all for it. And this is a good point where you can add yourself some error logic. So you would do something like this. Print string, and you really want to know something's going wrong here. Make it nice and death red right here. Make it last for 10 seconds so hard to miss. And then as for what we're going to say, and normally this would be entered into your log. It will show up under your log, but it's in code you can actually specify to the class and all that stuff. But that's beside the point. So what we want to start by putting is what the class is. So it's capture point. Okay, and then we're going to use a double colon, because that's your scope resolution operator. And then what is the name of the function? Determine scoring team. We can just F2 copy. We're going to put that on here. And we could have put a failure up sooner with the game state or whatever, but let's say we're not sure exactly what it is. We can just say error. I don't know, whatever you think. Unable to determine team and of players. You could say something like unknown condition, something just to grab your attention. You could get a lot more specific with these things, and you should. In the interest of time, I'm not going to go super into it, but in the debugging, you're really going to want that. That'll pop off. Another thing you could do for these sequences, you could get specific as to what each section is doing, because as this code grows, you're going to want to add, and so that way you're going to be wanting to move stuff down. So a quickly way to move stuff down would be like, oh, I could just drag this and move it. Drag this and move it. I mean, this might seem common sense, but I'll tell you what, man, I look at a lot of code, I mean, in AAA games, and it is not organized like this. And only, trained individuals will do it like this to make it expansive. Anybody who's done the job a while will do it like this, because they realize what a pain in the butt it is to come back even to their own code and modify things when you don't organize it like this. So this is good practice to get into, and obviously you wouldn't leave them white comment boxes. You would complete the comments and give detailed answers.